So good morning everyone, myself Vijay Dal from Department of Chemistry, roll number 21 NS0300. So I am in front of you all to deliver a short speech, or you can say that we had been given an assignment by our respected sir CP Khatioda to make a video presentation. So my topic of this presentation is going to be E is equal to mc square. So yeah, let's begin. E is equal to mc square is basically one of the most famous equation which was given by Sir Albert Einstein. It's also known as theory of special relativity, which expresses the fact that mass and energy are the same physical entity and can be changed into each other. So the first question that arises about this equation, that is E is equal to mc square, is what do you basically mean by E is equal to mc square? In simple words, it means energy equals mass times the speed of light squared. On the most basic level, the equation says that energy and mass, also known as matter, are interchangeable. They are of different forms of the same thing, which we can know basically. Why E is equal to mc square is so famous? This question arises uh, in every mind those who go through this equation, which is E is equal to mc square. Its fame is mostly famous because of its association with one of the most devastating weapons produced by humans, the atomic bomb. I think you all know about the historic event that happened in 1945 in Japan, in Hiroshima and Nagasaki. The equation appeared in the report prepared for the US government by physicist Henry D. Wolfe Smith in 1945 on the Allied efforts to make an atomic bomb during the Manhattan Project. This project had a great impact, or you can say E is equal to mc square. This small formula plays a major role in this most devastating weapons which was produced by humans. So the next question that arises about E is equal to mc square is that how does this equation affect us today? So yeah guys, this is basically a simple thing. Even though you probably never think about it, E is equal to mc squares affects practically everything that occurs in our world, even in our day-to-day life. Each time you bat an eyelid, flex a muscle, breathe in or out, think a thought, or beat your heart, you are converting mass into energy. And each time you digest a meal, you are converting energy. This all things, or this all phenomenon can be explained by E is equal to mc square in our day-to-day life. So yeah, now let's go to depth of the special relativity. So what is special relativity? Basically, this theory is based on two key concepts. First, the natural world allows no privileged frames of reference as long as an object is moving in a straight line at a constant speed, that is, with no acceleration. The laws of physics are the same for everyone. It's a bit like when you look out a train window and see an adjacent train appear to move, but is it moving or are you? It can be hard to tell. I think you all have felt that when you are traveling in a train and your train is moving in a rapid motion and the train next to you is not moving, it's in a uniform motion. I mean, it's not moving. It has its acceleration of 0. It's stable, but you feel like that the opposite train, the train that is opposite to you, you feel like the other train is also moving. But the question arises, is it moving or are you moving? It can be hard to tell. Einstein recognized that if the motion is perfectly uniform, it's literally impossible to tell, and identified this as a central principle of physics. Second, light travel at an unvarying speed of 1,86,000 miles a second. No matter how fast an observer is moving or how fast a light emitting object is moving, a measurement of the speed of light always yields the same result. I think you know about this law because it's quite famous for all those physics students. So, just now I stated you about, or I uh, explained you about special relativity in brief. So yeah, now let's go to the second option, because I'm not going to make this video a long video because we just have 15 minutes. So yeah, the second explanation is about what is general relativity. Essentially, it's a theory of gravity. Basically, the basic idea is that instead of being an invisible force that attracts objects to one another, gravity is a curving or wrapping of space. Basically, everyone knows about gravity, right? So, I think I don't need to explain about gravity. The more massive an object, the more it wraps the space around it. For example, the sun is big enough or massive enough to wrap space across our solar system, a bit like the way a heavy ball resting on a rubber sheet wraps the sheet. As a result, Earth and the other planets. As a result, the Earth and the other planets move in curved paths orbits it. This wrapping also affects measurement of time. Yeah, guys, we all know that this wrapping also affects measurement of time. What does relativity look like under the hood? We just know about it briefly, but do we know about the relativity in depth? So let's look at it. Special relativity is ultimately a set of equations that relate the way special things look in one frame of reference to how they look in another, the stretching of time and space, and the increase in mass. And the next relativity, that is general relativity, is more complicated. Its field equations describes the relationship between mass and the curvature of space and dilation of time, and are typically taught in graduate level university physics course that we are studying in our classes. So yeah, I think now you all know about E is equal to mc square in brief. So yeah, the most important part of this video is going to be the video of derivation. So yeah, let me show you some slide in which, or the slide will help you to know how to derive this equation. So yeah, let's begin the slide. This is the slide where we can see, consider a body that moves at very close to the speed of light. A uniform force acts on it, and as a result the force pumps energy and momentum into the body. That force cannot appreciably change the speed of the body because it is going just about as fast as it can. So all the increase of momentum, mass into velocity of the body is manifest as an increase of mass. I have shown a small figure that represents the force that is put into the balls. We have two relations between energy, force, and momentum from earlier discussion. Applying them to the case at hand and combining the two outcomes returns is equal to mc square. Now let's move towards derivation. First equation. The first equation is energy gained is equal to force into distance through which force acts. The energy gained is labeled E. Since the body moves very close to C, the distance it moves in unit time is C, or near enough. The first equation is now E is equal to force into C. I think you all got it. Now the second equation. This momentum gained is equal to force into time during which force acts. The unit time during which the force acts, the mass increased by an amount labeled m, and the velocity stays constant at very close to c. Since momentum is equal to mass into velocity, the momentum gained is m into c. The second equation is now force is equal to mass into c. Now by combining the both equation, that is E is equal to force into c and force is equal to m into c, we get that E is equal to force into c is equal to m into c, which comes, or if we simplify it, we get E is equal to mc square. The slide that I presented you is the simplest slide or the simplest way that you can derive E is equal to mc square. This is the most simplest derivation that you can get on the internet. So in the previous slide I presented you the derivation of E is equal to mc square in a simple way so that everyone could understand. I made the most basic slide that I could get. I hope you all understood the slide. So now let's get into the theory of E is equal to mc square. Basically, in 1905, Albert Einstein published two special articles. We can say special articles on the special theory of relativity. He completed his first paper in June on the properties of light and time. Then, just 3 months later, just 3 months, he finished a second, shorter article, essentially an addendum to his previous paper describing a very interesting conclusion about energy. No other scientists have invented this or had come to this conclusion about energy, that Einstein went on to present these findings mathematically. Energy E equals mass m times the speed of light squared, or we just can say is equal to mc square. The secret that this equation revealed was that mass and energy are different forms of the same thing, had eluded scientists for centuries. Einstein expected both of these revolutionary in 1905 papers to arouse a lively debate among physicists, but for months the often conservative scientific community was silent, and Einstein was disappointed by the lack of response. His isolation did not last long, however. However, by 1906, physicists from around Europe were journeying to Switzerland to discuss the intriguing new theory of the 27-year-old patent clerk. I hope you all know that before being a scientist, Albert Einstein was a clerk. It would be nice to think that Einstein's equation became famous simply because of its fundamental importance in making us understand how differently the world really is to how we perceived it a century ago. But its fame is mostly because of its association with one of the most devastating weapons produced by humans, which is the atomic bomb. The US government, by physicist Henry D. Wolf, as I have already mentioned, on the Allied efforts to make an atomic bomb during the Manhattan Project. The result of that project led to the death of hundred thousands of Japanese citizens in Hiroshima and Nagasaki, which you all should be informed with. I think you all know the incident, the I can say the brutal incident that had happened in Hiroshima and Nagasaki. Einstein himself had encouraged the US government to fund research into atomic energy during the Second World War, but his own involvement in the Manhattan Project was limited because of its lack of security clearness. It is unlikely that Einstein's equation was much used in designing the bomb, beyond making scientists and military leaders realize that such a thing would be theoretically possible, but the association has or had stuck. Coming to the end of this video, what do we understand basically from this E is equal to mc square, that is the theory of relativity? The equation says that energy and mass are interchangeable. They are different form of the same thing. I hope you all understood something by seeing this video about E is equal to mc square. And coming into the results and the conclusion, what we get is, if the object moves quickly, the mass is greater than the rest mass. The relativistic mass, I am giving pressure to the word relativistic because this mass is greater than the rest mass by an amount equal to the mass associated with the kinetic energy of the object. Massless particles also have relativistic mass derived from their kinetic energy equal to their relativistic energy divided by c square, or m real is equal to E by c square. Where we come to the equation. Coming to the end of this video, I hope you all got to know some basic idea, or I hope you understand basic things about is equal to mc square. So now I would like to end this video by saying a famous quotation by Albert Einstein, which is, a person who never made a mistake never tried anything new. So yeah, our professor Dr. C.B. Khateora had given us and such a beautiful opportunity of making this video, so we can learn many things regarding some new topics that we were not introduced to. So yeah, by saying this, I would like to end this video. Thank you everyone.